So for this last example, I'm going to encourage you to follow along with me. There's kind of a new wrinkle to this one that we haven't seen before. It's going to be another trig sub integral, but this one has limits of integration. So rather than going all the way through to the end and then plugging in our limits of integration, I want to show you kind of a shortcut we can do to make this easier. So let's start by identifying the trig substitution we're going to make. I notice I've got a square root and I've got an x squared in there, so it definitely feels like a trig sub. It looks the most like this last guy, the square root of u squared minus a squared. Okay, well if that's going to be the substitution, then apparently u should be x, and a, well, 3 isn't really a perfect square, but I could write a equals the square root of 3. It's not the most pleasant number, but it does work. Okay, so I'm going to go ahead and make that trig substitution I'm supposed to make here. I'm supposed to let u equal a secant theta. So I'm going to let u equal a secant theta. Here it is. Okay, so I have made my trig substitution. That was step 1. Step 2, I need to turn everything in this integral to be in terms of thetas instead of x's. So x, I've already got that. Let's find dx. I'll need that as well. So the derivative of both sides, I get dx equals, well, let's see, the derivative of secant is secant tangent. Okay, that's another thing we can grab from our formula sheet if necessary. Okay, kind of running off the end there. And the last thing I need is this square root of x squared minus 3. Now generally speaking, that square root term is going to turn into something nice. This is no exception. So let's see. If x is root 3 secant theta, then x squared is root 3 secant theta squared. So in other words, I'm going to get 3 secant squared theta minus 3. Well, let me factor out a 3 here. Secant squared theta minus 1 is just tangent squared theta. Okay, so I can rewrite this whole expression as just root 3 times tangent theta. Okay, so as usual, it came out to something decently nice. I now have all 3 components, so I'm going to plug them in here. I've got the integral from, and I'm just going to put something to something, because I haven't changed my limits of integration yet. So let's see, this square root term is root 3 tangent theta. On the bottom, x is supposed to equal root 3 secant theta, and dx is root 3 secant theta tangent theta d theta. Okay, let's clean that up a little bit. Secant theta over secant theta, that's gone. Root 3 over root 3, that's gone. What I end up with here is root 3 times the integral of tangent squared theta d theta. Okay, so let's pause for a second and take stock of what we have. I now need to do the integral of tangent squared theta. So turns out, hidden inside the problem I was working on, I now have a trigonometric integral. Right? I've got some tangents or secants multiplied together. In this case, it's just tangents, and I need to know how to deal with that integral. Okay, so let's see. How can I deal with the integral of tangent raised to an even power? I'm just supposed to turn that into secants. So instead of writing tangent squared, I'm going to write secant squared theta minus 1. Okay, so now the integral of secant squared theta is tangent theta, and the integral of 1 is just theta. Okay, so once I recognized what pattern I saw here, this is a very doable integral. Okay, but this is the point where I need to deal with those limits of integration. There's 2 approaches I could take from here, and this is why I wanted to go over this one with you guys. Okay, I could go through my process where I draw my triangle, turn everything back in terms of x's, and then plug in my limits of integration. But it turns out what's generally a little bit easier when I'm doing a trig substitution is just converting my limits of integration. Okay, normally I don't love doing that, but here I think it saves some time. So all I need to do now is figure out, okay, these limits of integration were for x. Let's figure out the corresponding limits of integration for u. Well, not u, sorry, theta, said the wrong thing. Alright, so if x is going to equal, let's start with the bottom one, root 3. Then let's do the other side of this equation. Root 3 equals root 3 secant theta. Okay, so that means 1 equals secant theta. I just need to think, when is secant theta equal to 1? So if I flip both sides upside down, I've got cosine theta equals 1. Well, cosine theta is equal to 1 when theta is equal to 0. So that first limit of integration is going to be theta equals 0. Alright, now let's work on the second one. Same equation here. I've got 2 equals root 3 secant theta. Alright, so let's see. 2 over root 3 equals secant theta. If I flip both sides upside down, I've got cosine theta equals root 3 over 2. So I just need to think, when is cosine theta equal to root 3 over 2? Well, that's going to happen when theta is equal to pi over 3, pi over 6, or when it's equal to negative pi over 6. Okay, so we kind of have our choice. Just for convenience, I'm going to go with pi over 6. Okay, there's multiple correct answers here, but generally I don't want to do the more complicated one if I have a choice. So I'm just going to go with theta equals pi over 6. So my limits of integration in terms of theta are going to be 0 and pi over 6. So again, could I have drawn out my triangle, converted everything back in terms of x, and then used my original limits of integration? Yeah, I could have. But I'm just going to completely cut out that middle step where I do the triangle here, and now plug in my new limits of integration. Okay, so let's start by plugging in pi over 6. And then we'll finish by plugging in 0. Okay, the good news is the tangent of 0 is 0, and that's just 0. So I really just need to deal with this term. So let's see, the tangent of pi over 6. That's going to be 1 over root 3. And here I've just got pi over 6. So this is 1 minus pi root 3 over 6. So once again, I never had to draw my triangle here to turn things back in terms of x's. I was able to just convert my limits of integration to be in terms of theta, plug them into my integral, and get an answer.